Look at your hand. Hold it up. Look at it. That is the most immediate thing in your world right now. It is closer than the wall, closer than the screen. There is no gap between you and your own body. Except there is. The light that left your skin just now is still traveling. It has not arrived yet. The hand you think you are seeing is already gone. You have never seen the present. Everything your eyes have ever shown you is already gone. You have looked at your hands thousands of times. Every single time, you assumed you were seeing them now. That instinct runs so deep that questioning it feels absurd. But sight is not a live feed. It is a delivery system, and delivery takes time. No version of this changes at closer range. It only gets smaller. Light is fast. Roughly 300,000 kilometers every second. Nothing travels faster. But fast is not instant. Even at that speed, it takes time to cross a room. At arm's length, the delay is about 1 to 2 nanoseconds. A nanosecond is 1/1000th of a second. That is a number so small it means nothing on its own. So here is what it means. Light covers roughly 30 centimeters per nanosecond. That is about the length of a ruler. The version of your hand you are looking at right now departed your skin approximately 1 ruler length of time ago. It is the freshest possible past, but it is the past. This is the version of the problem your brain always dismisses. 1 nanosecond. Who cares? In daily life, the difference between the hand that left and the hand in the image is 0. Nothing has changed. No cell has moved far enough to matter. The delay is physically real but practically invisible. Your brain files it under irrelevant and moves on. And this is exactly how the error survives. Not by lying, by being too small to notice until you ask what happens when the distance gets larger. Your friend's face across the dinner table is a few nanoseconds old. The wall across the room is 5 to 10 nanoseconds old. The building you see from your window, if it is 100 meters away, is reaching you roughly 300 nanoseconds after it existed. Still nothing you would feel, still nothing that would change any decision you make. But the mechanism is identical, the same process, the same physics. The delay is just compressed to the point of invisibility. Now move the distance. The moon is roughly 384,000 kilometers away. Light covers that gap in about 1.3 seconds. The moon you see tonight is the moon as it existed 1.3 seconds ago. That is not a metaphor. When you look at the moon, you are seeing a record of it from 1.3 seconds in the past. If something had happened to it 0.9 seconds ago, a new crater, a sudden change, you would not know yet. You would still see the old version. You would see something that no longer exists. The sun is further, about 150 million kilometers. At light's maximum speed, the crossing takes 8 minutes and 20 seconds. The sun you see right now is the sun as it was 8 minutes ago. Whatever is happening there at this moment, any shift on its surface, any eruption, has not reached you yet. If the sun vanished right now, you would not find out for over 8 minutes. You would still see it burning in the sky, you would still feel its warmth, and it would already be gone. That distance is still inside our own solar system. In 1676, a Danish astronomer named Ole Rømer was working at the Paris Observatory, tracking the moons of Jupiter. He was measuring the timing of eclipses, moments when Jupiter's moon Io passed behind the planet and reappeared. The pattern should have been perfectly regular. It was not. When Earth was moving toward Jupiter in its orbit, the eclipses came slightly early. When Earth was moving away, they came slightly late. Rømer did not know what he was looking at immediately. The data accumulated. The pattern refused to go away. He eventually arrived at the only explanation that fit. Light was not instantaneous. It took time to cross the distance between Jupiter and Earth. The eclipse was early when the distance was shrinking, late when the distance was growing, because the light had less or more space to cross. Rømer calculated the speed of light from this discrepancy. His value was off from the modern figure, but the principle was correct. He had proven, for the first time, that seeing and happening are not the same moment. That the information in your eyes left its source at a specific instant in the past and took a measurable amount of time to arrive. The scientific community disputed him for years, not because the math was wrong, because what he was describing violated the deepest perceptual assumption any human had ever held. The idea that you are always watching the past, even across a room, felt wrong in the body, not wrong in the math, wrong in the gut. It took decades before the measurement was confirmed well enough to stop the argument. Rømer did not live to see the consensus settle. The mistake he had to fight was not ignorance. It was certainty. The certainty that what you see is what is. That certainty still runs in every person alive. It is older than any science. It has never been useful to correct it until now, because at room scale the error is too small to feel. The brain never evolved to notice a nanosecond. It evolved to catch a thrown rock, to track a moving animal, to read a face. At those scales, treating vision as a live feed is accurate enough to survive on. But accurate enough to survive on is not the same as true. The nearest star beyond our own sun is Proxima Centauri. It is roughly 4.2 light-years away. That means the light reaching your eyes from it tonight left its surface 4.2 years ago. Not last week, not last year, before the last election cycle. Anything that has happened to that star since then is information that has not arrived. An explosion, a collapse, a change in brightness you would not know. You are not seeing Proxima Centauri as it is. You are seeing it as it was. Move further. The Andromeda galaxy is the closest large galaxy to ours. It is roughly 2.5 million light-years away. The light arriving at your eyes from Andromeda tonight left its source 2.5 million years ago. That is not a rounding error. When that light departed, modern humans did not exist. The species that would eventually build telescopes to receive it had not yet appeared. The galaxy you see on a clear night in the northern sky is an image of an object from before our species was born. Its current state is completely unknown. It will remain unknown for millions of years. This is not about distance. It is about what seeing means. Your eye can only detect light, not objects, not events. Light, an object exists, emits, or reflects light, and that light travels to your retina. The retina converts it to a nerve signal. The brain assembles the signal into an image. At every step, what you end up with is a record of a past moment, not a current one. The present state of any object you look at is accessible only to an observer standing at zero distance from it. That is physically impossible. Zero distance means occupying the same space. Every observer, everywhere, is always receiving light from the past. The present tense, as a visual category, does not exist. It never has. Every image you have ever seen was already history by the time it reached you. Most people hear this and find an exit. The delay in daily life is negligible, so for practical purposes, now is a useful concept. Run that to its conclusion. The delay at arm's length is 1 nanosecond. The delay to the moon is 1.3 seconds. The delay to the sun is 8 minutes. The delay to Proxima Centauri is 4 years. The delay to Andromeda is 2.5 million years. There is no line in that sequence where the physics changes. There is no threshold where light suddenly stops being subject to travel time. The delay scales with distance, continuously, from the ruler in your hand to the edge of what any telescope has ever seen. The only thing that changes as you move up that scale is whether the gap is small enough for the brain to dismiss. Small enough to dismiss is not the same as zero. The night sky makes this explicit in a way nothing else can. When you look at the night sky, you are not seeing the universe. You are seeing a mosaic assembled from light of radically different ages, all arriving at your retina at the same moment. The star closest to you might be 4 light-years old in your view. The star next to it might be 400 light-years old. A dim smudge near the horizon might be a galaxy billions of years back. All of it landing simultaneously on the same retina, on the same evening, in the same 2 seconds you spent looking up. None of it current. All of it labeled now, by a brain that has no mechanism to sort by age of signal. Some of what you see no longer exists. Stars die. They run out of fuel and collapse. Some collapse quietly. Some detonate in explosions so powerful the flash outshines entire galaxies for a few weeks. When a star dies in that second way, a supernova, the explosion sends out a wave of light in every direction. If that star is 1,000 light-years from Earth, the light from its death takes 1,000 years to arrive. For 1,000 years after the explosion, anyone looking at that star from Earth sees nothing wrong. The star looks normal. It looks alive. It broadcasts old light the whole time, steady and unremarkable. Then one night, 1,000 years after the event, the wave of death arrives. The star flares to a brightness visible in daylight for weeks, and then the old light runs out, and the star is gone. What you saw as normal for 1,000 years was a corpse sending old messages. What you saw explode was an event that happened before your civilization had invented writing. There is no way to know, on any given night, which stars in the sky are still burning. The observable universe has a hard outer edge defined by light travel time. The universe is roughly 13.8 billion years old. Light that departed a source 13.8 billion years ago has only just had time to reach us. Not because it does not exist, because its light has not had enough time to travel here yet. Cosmologists estimate the full universe is vastly larger than the part we can see. The observable portion, everything within reach of our telescopes, is a sphere defined by how much time has passed since the beginning. It is not a map of what exists. It is a map of what light has had time to deliver. The universe outside that sphere is not dark. It is simply not yet in contact with us. The information from it is still in transit and will remain so for billions of years. The obvious response is to try to fix this with better instruments, larger telescopes, faster detectors, higher sensitivity. These improve what you can see. They do not change when you see it. A larger mirror collects more photons from a distant galaxy. More photons means a sharper image of a thing that existed billions of years ago. The telescope does not pull information forward in time. It amplifies what has already arrived. The age of the signal is determined by the distance between the source and the detector, not by the quality of the detector. A space telescope orbiting far above the atmosphere sees with extraordinary clarity. It still cannot see the current state of anything more than a few light seconds away. The sharpest image ever taken of a distant galaxy is an exquisitely detailed picture of a galaxy that may no longer exist. Resolution and latency are two separate problems. Better resolution does not touch latency at all. Move closer then. If the delay is caused by distance, reduce the distance. This works, within limits. Moving from across the room to arm's length cuts the delay from roughly 10 nanoseconds to 1 or 2. That is a real reduction. Moving from Earth to the orbit of the Moon would cut the 1.3-second delay down to milliseconds. Every meter you close reduces the gap, so the fix seems obvious. Get as close as possible to the things you most need to see in real time. But this only works at scales where physical travel is possible. You can walk across the room. You cannot walk to Proxima Centauri. The average speed of our fastest spacecraft would take roughly 73,000 years to cover 4.2 light-years. Moving closer is a solution that collapses at exactly the scale where the problem becomes philosophically serious. At room scale, where you could close the distance, the delay is already too small to matter. At stellar scale, where the delay becomes years, centuries, or billions of years, the distance is physically uncrossable. The fix is available only where it is not needed. There is a second layer to this that most people never reach. The concept of a universal now, a single shared moment experienced identically by all observers, does not exist. This is not a philosophical position. It is a consequence of the same physics that limits the speed of light. Two observers at different locations receive photons from the same event at different times. Their experience of when the event happened is genuinely different. An observer on a spacecraft moving away from a star receives its light later than an observer moving toward it. Both are receiving real light from a real source. Both are building a real picture of when that source existed. The pictures do not match. They cannot match. There is no privileged frame of reference from which a single universal now can be read. The present moment is not shared across space. It is local. It is personal. It ends at the edge of your atmosphere, and even there, it is already nanoseconds old. The problem with the fix of moving closer is not just practical. It reveals something about the structure of the original claim. If the delay only matters at scales you cannot close, then for all human purposes, the present is effectively available. The room around you is current enough. Your friend's face is current enough. The delay is there, but its size makes it irrelevant. Except irrelevant is not the same as zero, and the brain does not file irrelevant things as false. It files them as true and small. The result is that the assumption of simultaneity survives intact in every context where you cannot test it. The feeling that what you see is happening now does not dissolve. It cements, and the assumption then transfers, silently, to the stars. This is where the two halves of the problem lock together. At room scale, the delay is real, but feels like zero. At stellar scale, the delay is real and enormous. But the assumption was built at room scale and was never designed to carry a disclaimer when it scaled up. So it doesn't. You look at a star the same way you look at a wall. The brain applies the same label. This is happening now. The mechanism that should flag the difference, some sense that this light is old, does not exist. It was never built. There was never any evolutionary pressure to build it. No ancestor survived or died by correctly identifying starlight as 4-year-old information. The brain that never distinguished between fresh and ancient light lived just as long as the brain that did. The assumption moved intact through every generation, across the entire history of human sight. No correction signal was ever strong enough to override it. Every person who has ever lived and looked at the night sky applied the same wrong label to the same ancient light. None of them had the tools to notice. The tools that would eventually let people notice arrived so recently in human history that they have barely registered. Telescopes, spectrometers, radio arrays, all new. The instinct underneath is ancient. The knowledge that starlight is old is available in every physics textbook. The feeling that you are watching the present is available in every pair of human eyes. The knowledge and the feeling do not compete, because they operate in completely different systems. The James Webb Space Telescope, orbiting roughly 1.5 million kilometers from Earth, currently images galaxies as they existed less than 1 billion years after the universe began. It does this with a precision no previous instrument matched. The images are extraordinary. They show galaxies in formation, structures that no longer exist in anything like that form. Webb will continue operating and continue extending the reach of the visible past. It will deliver records of earlier and earlier moments in the universe's history. It will not show anyone what is happening in those galaxies now. It cannot. No improvement to its mirrors, its sensors, or its orbit will change the age of the signal arriving at its detectors. Webb observes the past more clearly than anyone before it. The present state of any object it studies is not available to it. Not to any instrument humanity has ever built. Not to any instrument humanity will ever build at any distance greater than 0. Your hand is 1 to 2 nanoseconds old to your own eyes. The light from the most distant object Webb has ever imaged took over 13 billion years to arrive. Between those two numbers, no observer has ever seen the present. The universe allows only one kind of sight, a view into history, at a distance-determined delay with no option to upgrade. The next generation of instruments will see further back. They will not see forward at all.